During last lecture, we discussed about file management. Okay, the file management, how the files are allocated in the secondary memory. Okay, and then how the disk scheduling will happen. Okay, how the disk scheduling will happen through algorithms, through some, those are called, those techniques we discussed, no? First to come, first in, first out, and shortest seek time first, scan algorithm, C scan algorithm, look algorithm, C look algorithm. All these are the algorithm we did not study, but we saw examples. We understand through the examples how the IO scheduling will happen. Input output request will be fulfilled. Okay, so that we discussed. And now we are going to discuss about the deadlock. Where the deadlock will happen? Deadlock may happen in your system, in multi-processing system. There is a chance to happen deadlock. Okay. What is deadlock? Before going to the proper definition, because if I say the definition, then it is difficult for you to understand it. So through example, I will explain. Assume that there are two processes. Very simple example, we will assume only two processes. Process 1 and process 2. There are two processes. Okay. Process 1 is having one resource. Okay. Assume that R1. Process P1 currently holding resource R1. Okay. Process P2 currently holding resource R2. The resource can be anything. We will discuss that. It could be hardware resource or any software resource. Software resource means what? Database table. In the table, some particular record. So that could be what? That could be the software. So any resource, we are not going to mind about that whether it is hardware resource or software resource. In our example, there are two processes P1, P2. There are two resources R1, R2. P1 is currently possessing resource R1 and P2 currently having resource R2. Okay. P1 did not release the resource R1, but it wants resource R2. P1 is keeping resource R1, but it is requesting for resource R2. Where is R2 currently? R2 is with the process P2. Okay. So what process P1 is holding one resource and requesting for another resource. Okay. One resource, which resource it is holding? Resource R1. R1 it is holding and it is requesting for R2. Where is R2 currently? R2, resource R2 is currently with process P2. Okay. This is the state of process P1. On the other hand, process P2, what it is doing, it is holding resource R2, but it is requesting for resource R1, which is currently held by process P1. Okay. Now, what is process P2 is doing? Process P2 is holding one resource and requesting for another resource. Same as process P1. But what P1 is requesting now, no, that is with the P2 now currently. What is P2 is requesting? That is currently with the P1. Okay. Now this situation is called a deadlock. That means to complete the process, to complete the task, okay, to complete the task, process P1 wants resource R2, but it will not get. To complete the task, process P2 wants resource R1, it is also not going to get. So this will create a deadlock. This will create a deadlock. Okay. Now, even you can assume some real-time situation also. in a traffic, assume that both the ways are allowed. Okay, it is not the single way path. Okay, both the direction vehicle can go. The path is very narrow. Okay, single vehicle can go. Four-wheeler means single four-wheeler can go either from either in either of the direction. Okay, only one vehicle can go. Assume that there is a complete traffic happened because in two opposite side two four-wheeler came. Okay, so now what will happen? These first two car are in deadlocked situation. Deadlocked situation. Okay, because both the car cannot go behind it because behind also there are vehicles. The left side car also cannot go back and the right side car also cannot go back. And at the same time, both the cars cannot step forward also, cannot move forward also. Okay, so this is called deadlock. Okay, now simply this deadlock should not happen. What should be done? The way should be the single direction way. Okay, or otherwise any other systematic, some protocol should be implemented to avoid the deadlock. Okay, so the same way here on resources, there are many resources, printers, scanners, plotters. There are many shareable resources. Those shareable resources, when one process is holding the resource and it is requesting for another resource to complete the task, but it is not getting, then the deadlock may happen. Okay. So now, what is the definition of deadlock? What is the definition of deadlock? In any multiprocessing system, in any multiprocessing system, in any wait, Riya. What do you want?
What is Deadlocks?
So in a multiprocessing system, each process, in a multiprocessing system, assume that there are many processes. Okay, in a multiprocessing system, each process in a set of processes, each process in a set of processes request a resource which has been allocated for other process without releasing the holding resource. Okay. Now in our example also, process P1, if it wants to use resource R2, it has to release whatever resource currently it is having, and then it has to request for the resource. Then deadlock wouldn't happen. Okay. But that is not done by the process. Both the process holding some resource and it is requesting for another resource. That's why deadlock happened. So in a multiprocessing system, each process in a set of processes request a resource which had been held by another process. Okay, this each process without releasing the resource which expect the other process should release the resource. Okay.
Ma'am, can you repeat the definition again?
In a multiprocessing system, this is there in your textbook. Okay, in a multiprocessing system, each process in a set of processes, each process in a set of processes requests a resource which had been allocated for other process. Request a resource which had been allocated for other process or another process without releasing the currently holding resource. Without releasing the currently holding resource. Without releasing the currently holding resource. So this is called a deadlock. Okay. Okay. Now you have to know what are resources. Resources can be printers, tape drivers, or it can be database tables. Okay, or it could be any data structure. These are the tape drives, printers, scanners, all those are hardware resources. Database related components are what? Software resources. Resources can be available in a single instance. That means when we are talking about the printer, it is not necessary one system will be connected with one printer. Okay, it can be connected with more than one number of printers, more than one number of plotters. Okay, so that we have to know. Okay, so when we are talking about these resources, it can be the single instance of resource or multiple identical copies of resources. For example, there are many array of tape drives. Okay, so there are in the type of the resources one, but the quantity is more. Okay, so that is a resource can be available in any one of these two forms. For example, a system can have only one printer, or the system can be attached with more than one number of printers. Okay. So, for example, one is a color printer, one is a black and white printer, something like that. Okay. So, it is not necessary that resource should be one type of resource should be only one available in the system. Okay, it is not necessary. So, resources can be preemptible and non-preemptible. Okay, preemptible means what? The resource can be taken away from the process with no negative side effects. Negative side effects means what? Now, as I said, the deadlock happened between the process P1 and P2. Okay. Now, if suppose that is a preemptible system, okay, we can preempt the resource. What we can do, we can either remove the process R1 from P1 and we can give it to P2, or we can remove means what? We can preempt, we can take away the resource R2 from P2 and we can give that resource R2 to P1. Okay, so that is allowed in some of the system. Okay, in some other systems it is not allowed. Okay, so you should know the preemptible or non-preemptible system. The system is preemptible or non-preemptible system with respect to resource. Okay, so that means the resource can be taken from the current process, or it cannot be taken from the current process. That means it cannot be taken means what? The process it has to complete its work and then the process itself, it will release the resource. Okay. The process itself only can release a resource. Operating system cannot, if deadlock happen, it cannot take away the resource from the process. Okay. So that is non-preemptible. Okay. You should understand preemptible means what? It is allowed to the operating system to take away the resource from any of the processes. Okay. Non-preemptible means the process itself can release the resource, but the operating system cannot what? Cannot take the resource from the currently processing process. Okay. So that is preemptible. These are basics. Before we are going into deadlock, we have to know. Okay. Deadlock occur when processes are granted exclusive access to non-preemptible resources. So where the deadlock occur, wherever the non-preemptible system, whichever system is a non-preemptible system, there only what? The deadlock can occur. Otherwise, when the deadlock happen, even the simple example we saw, no? If it is preemptible, what we can do? The operating system can remove the resource from any one of the process and give it to another process. No, that is preemptible. Okay, that is possible only in preemptible system. Okay, so we are talking about the deadlock only in non-preemptible system. That means the resources are non-preemptible. The shareable resources are non-preemptible. Then only the deadlock can occur. Okay. Sequence of events required to use a resource. Suppose a process wants to take a resource. Process wants to take a resource. Okay. And it wants to use the resource. Okay. What are the steps the process should follow? It has to first request the resource. When it is requesting the resource, no, if the resource cannot be allocated by the operating system, then this particular requested process, no, it will go to waiting state. Remember, okay. The first step is what? Now there is a process P1. It wants to use one particular resource. Okay. Now, what are the steps the process should follow to acquire that particular resource? First, it has to request the resource. It has to request the resource. But when it is requesting the resource, all the time it will not be immediately allocated. Okay, because if the resource is not available or currently used by any other processes, then the resource cannot be allocated. The requested resource cannot be allocated by the operating system. That time what the process will do? The process will go to waiting state. Waiting for what? Waiting to acquire the particular resource. Okay. So if it is possible, immediately it will be allocated. If it is not available, it has to wait. That's it. The process should wait. Okay. Then in the next step, if suppose the process granted the request. Okay. So then what will happen? The process will get the resource to use. So using the resource, the process will complete the task. That is use the resource. So for what purpose it is requested the resource, that task it will complete. Okay. Okay. After completing the task, the particular process should release the resource. It is that simple. So sequence of events required to use a resource by a process is what it has to first request. If it is available, it will be allocated, or otherwise it has to wait. Okay, till the particular resource got released. Okay, and then it can use it, and then it has to release. The process should release the resource. Okay, because the resource we are talking about the resource which are shareable resource. Private resource we are not going to talk about only, because private resource will be used by only one process. Okay. Okay. This is what I said here. If request is denied, requesting process may be go to blocked or may fail with the error code. So this you can assume it will go to wait state. Okay, but in some of the systems, the waiting time will be what? That has boundary. Okay. So if suppose 2 millisecond is maximum waiting time. So after 2 millisecond, the system will fail. That means that the request will be eliminated. Again, it has to request. The process should request. Okay. Already it is requested, it is waiting. Okay. Rarely some of the system to speed up the process speed, they will implement the maximum waiting time. Okay. So in that case, what? With error, it will exit. Okay. But in that case, it has to again place the request. Okay. Defining deadlocks. So here, even this also you can write a set of processes is deadlocked if each process in the set of processes is waiting for an event that only another process in the set can cause. Okay. So this can also be written. Okay. a set of processes is deadlocked, how we can say 2 or 3 processes, the set of processes got deadlocked? Okay. How in our example we said process P1 and P2 got deadlocked? How? This condition satisfied. If each process in the set, that means all other process in the set is waiting for an event that only another process in the set can cause. So one is depending on another in as a chain in a circular manner. Okay. A is waiting for B to release a resource. B is waiting for C to release a resource. C is waiting for D to release a resource. SA. Okay. The chain will be formed. Okay. We have taken simply 2 processes. I am talking about now multiple processes. In this A, B, C, D, E, F and all what processes. Okay. So A is waiting for B. For what? B should release one particular resource. B is waiting for C to release a particular resource. So C is waiting for D to release a particular resource. Again, D is waiting for E is waiting for F is waiting for again A. Okay. So that is deadlock. Okay. Usually the event is the release of a currently held resource. So we have to somehow release any one of the, in this chain, any one of the process released a single resource, then the deadlock will not happen. Deadlock will be released. Okay. It will be solved. Okay. Now, if the deadlock happened, what will happen? If deadlock occurred, what will happen? None of the process can run. None of the process can release a resource. None of the process can be awakened. That means all the process will go to what? Waiting state, sleep state. Okay. So this will be the problem if deadlock happened. Okay. And starting from here, it is very important. The questions may come from this. Okay. 4 conditions to occur deadlock. Okay. How exactly we will find it is deadlock? Now, orally, when I'm saying, I can say P1 is depending for P1 is waiting to P2 to release some resource and all. But there are 4 conditions should be satisfied to confirm that yes, the deadlock occurred. Yes, the deadlock occurred. Okay. Now, these are the conditions which will cause the deadlock, which will cause the deadlock. Okay. The first condition is mutual exclusion condition. We discussed about the mutual exclusion. Okay. There is a semaphore. Semaphore will allow only one one process to go into the critical section and all. Okay. So mutual exclusion condition. Because of the mutual exclusion, also what? Deadlock occurs. Okay. And hold and wait. Hold and wait means what? This is very simple. Every process, every process which are in deadlock, it will hold one resource and request another resource. So that's holding one resource, one or more resources. Okay. It is holding something and waiting for the another one. Okay. Because of this only what? Deadlock is occurring. Hold and wait condition. Every process is holding something and waiting for something. What it can do, it can release whatever resource it has, and then it has to put the request for another resource. Then deadlock will not happen. Okay. So it is holding some resource and waiting to get another resource which is possessed by another process. Okay. That's why deadlock occurs. Okay. No preemption condition. This I already said. Okay, the preemption is not allowed. That is also the reason to occur deadlock. Okay. Circular wait condition. Circular wait condition means what? As I said, there are 5 processes. Process 1 waiting for P2 to release a resource, and process P2 waiting for P3 to release a resource. Process P3 waiting for P4 to release a resource. Process P4 waiting for process P5 to release a resource. Process P5 is waiting for process P1 to release a resource. So there is a circle. Okay, that forms the circular chain waiting. Okay, because of this, the deadlock happens. Here, one thing you have to understand: if deadlock happens, all these four the conditions will be satisfied. Then only the deadlock will occur. It is not like any one of the conditions satisfied, it will cause the deadlock. No. All the four conditions should be satisfied. Then we can confirm that yes, it is a deadlock. There is a mutual exclusion condition. That means each resource is assigned to exactly one process, or it is available. So if you take each and every shareable resource, currently available in the multi-processing system, if you look at each and every resource, either it will be used by a single, the word single is very important, single process. Either it is used by a single process, or it will be freely available. Any one. The resource should be in any one of these conditions. Okay. Which condition is not satisfied here? A resource, a single resource cannot be allocated to more than one number of processes. That's why it is leading to deadlock. But actually it is not possible, at a time allocating single resource to more than one number of processes is not possible. That's why we implemented semaphore. Okay, so semaphore will take care. Okay, one resource should be used by one process only because it is a shareable resource. Okay, so the shareable resource can be used by single process only. Okay, but this became a reason to occur the deadlock. Please understand, this became a reason to occur the deadlock. Okay, next, hold and wait. Each and every process is holding a resource and requesting for a resource. What is the other hand? The other hand is what? If the process wants to request any resource, it has to release all the resources, shareable resources. Only shareable resources it has to release, and then it has to put a request to use the another resource. Then the deadlock wouldn't have happened. Okay, so that is a hold and wait condition. And every deadlock, if you look at, mutual exclusion would be there, hold and wait condition will be satisfied, and it would be no preemption system, and the deadlock happens, there will be a circular wait. A is waiting for B, B is waiting for C, C is waiting for D, D is waiting for again A. That will be there. So all these four conditions are satisfied, then we can say that there is a deadlock. There is a deadlock. Okay. Usually, to detect the deadlock, to find whether deadlock happen or not in the system at any instance of time, we will use a directed graph. We will use a directed graph. Students, any disturbance from my side? Any noise?
नहीं ना अभी तो ज़्यादा सुनाई नहीं आ रहा
Okay. Okay. So what is this, all this diagram? We want to detect in one particular system, multi-processing system, whether the deadlock happen or not. Okay. How can we detect? How can we detect? We will use some graphical notation because that is easily we can find that whether deadlock happen or not. Okay. That graphical notation, representation is called directed graph. Okay. Using directed graph, what we can do? We cannot avoid the deadlock. We cannot prevent the deadlock. We cannot recover the deadlock, but we can detect the deadlock. We can detect the deadlock, whether deadlock occurred or not, we can find. Okay. Okay. Now in this directed graph, what are the elements would be there? Processes. Processes are represented using circles. So now here in this diagram, A is a process. In this diagram, B is a process. In this diagram, D and C are the processes. Okay. So circles represents what? process. Okay. The name of the process will be written inside the circle. So now this is process A, this is process B, this is process C, this is process D. Okay. Resources. Resources will be represented using squares. Okay. Now this is a resource. Okay, so it is in square. Name of the resources are. This is another resource. Yes. These are two resources T and U. Okay. Okay. So circles are processes. Squares are resources. Okay. Now what this diagram represents? Resource are assigned to process A. Now this is resource R. Currently resource R is assigned to process A. How I am saying it is assigned to process A? Because look at the arrow which is going towards the process. That means if you are being on the position of the process, if you see where the arrow is coming towards the process, so that the process is currently holding the resource R. Holding the resource R. How I am saying it is holding? How I am saying it is holding? Because the arrow is coming towards the process. That means the process is currently having this resource. Having this resource. Okay. If this arrow goes opposite side, if this, that is not here, that is not given here. Okay, assume this arrow is going opposite sides. What it represents? It represents process A is requesting for resource R. Process A, because the arrow is going where, in which direction? Arrow is going from away from the A, away from A. It is not towards A, it is away from A. So process A is requesting, it is not getting, it's not a God. Okay, it is requesting the resource R. But as per this diagram, process A is possessing, holding the resource R. Okay, we can say in another way also. Okay, I said with respect to process. Okay, I can say with respect to R also. How can I say? Resource R assigned to process A. Resource R is assigned to process A. Okay. See, look at this diagram. Process B. Okay. You always go with respect to process B. Process. Okay. So process B, now process B, where the arrow is going, there is one process and one resource. In between, there is arrow. Okay. So now what? The process A is requesting the resource yes. It is not possessing. It is not holding the resource yes. It is requesting. It is requesting the resource yes. How I am saying it is requesting? Because look at the arrow. Okay. The direction of the arrow is going away from the process. So it is requesting. Okay. This A, process A, is currently possessing the resource R. Process B is currently requesting for resource yes. Okay. Now this is deadlock. This diagram denotes deadlock. Why? Look at the process. Process D. It is requesting a resource U. Process D requesting the resource U by possessing resource T. Which means, look at the process D. Process D is having currently which resource? T. T is with process D. But it is requesting what? It is requesting another resource, which is U. Okay. Is this clear? Process D is holding resource T, but it is requesting resource U. Okay. Look at process C. Process C is requesting resource T by holding resource U. Okay. Resource U is currently requested by process B, but it is held with process C. Okay. Resource T is currently with process D, but it is requested by process C. Okay. So what C wants, it is with D. What D wants, it is with C. Okay. So this is called a deadlock. Is this clear? Okay. Now, how the deadlock occurs, step by step, how the deadlock occurs. Students, these are very simple. Okay. You have to just listen. Okay. If you listen, all these concepts are very simple. Okay. Now, process A request resource R. This is the first event happens in a multiprocessing system. Assume that all the processes, all the resources are free now in an initial state. None of the resources are allocated to any process. That is the initial state of the multiprocessing system. None of the resources are currently allocated to any processes. Okay. So all the resources are free now. What are the resources? RST are the resources. What are the processes are there in the multiprocessing system? A, B, C. These are the processes. Okay. What is the first step? What is the first request? A, process A is requesting R. Okay. Process A is requesting R. Will it get or not? Will it get or not? It will get, because that R resource R is free now. It is not allocated to any other process. So it will get. Yes. Step 1 done. Okay. Step 1. Now after the step 1 done, your image, the picture will be like this. See, R allocated to A. That means A currently, a process A is currently holding resource R. Right? Okay. What is the next step? B request yes. B is requesting yes. Okay. Will it get? Yes, it will get, because yes is free now. Okay. So that is shown here in this diagram. Okay. Now B is holding yes, resource yes. Okay. Third request, C request T. Now C, process C is requesting T. It will get, because resource T is free now. It is not allocated currently with to any of the processes. Okay. So T is free. So C requested T. Yes, it got allocated. So after allocated, the diagram will be like this. Graph will be like this. Now currently A is holding R, B is holding yes, C is holding T. Okay. Now what is the fourth request? Fourth request, A request yes. A is requesting yes. Look at this diagram. This diagram is repeated as it is with only one change. What is that? A requests yes. A is requesting yes. So how the arrow is going, in which direction? Observe. Okay. Because now here A is requesting the resource yes. Okay. But A is already holding what? Holding the resource R. Okay. What is the fifth request? B requested T. B is requesting T. Okay. So the arrow will come like this. B is requesting T. Okay. Now what is the state? A is holding R and requesting yes. B is holding yes but requesting resource T. Okay. What is the last one? C requests R. Khatam ho gaya. Now here what? Deadlock is going to happen. C request R. C is already having T, but it is requesting R. Okay. So C requests R. Okay. Now look at this. There is a circle happens. Okay. A is having R requesting yes. B is having yes requesting T. C is having T but requesting R. Okay. So none of the process, all these processes cannot go forward. It got locked. But the lock is what? It is a deadlock. Okay. It's a deadlock. Means there is no way to release until otherwise to apply something. That we will see. There are 3 deadlock recovery technique. Okay. Recovery technique that we will discuss. So we have to apply any one of the recovery technique. All these recovery techniques are very which has its own disadvantage, drawback. Okay. So applying recovery technique is not not a suggestible one, but there are ways we have to know there are recovery techniques. Okay. So this is deadlock. Okay. Now another example where no deadlock. If you go through the diagram, you will come to know. Okay. Now process A, all the resources are free. Process A is requested or it got it. Okay. Process C requested T, it got it. Okay. In the third step, what is happening? Process A requested yes. Now currently S is also free, no? So it got it. Okay. So now currently A is having R and S, C is having T. Okay. So there are 3 steps over. Fourth one, C request R. C is requesting R. Okay. A releases yes. A is what? Releasing the yes. A is releasing the yes. Okay. A releases yes. So somebody who requested yes, no, they can use it. So A releases yes. So that who requested, A requested yes. A releases yes. Okay. So it is just a simple example. Okay. So now when this way the allocation and releasing of the component happen, there is no deadlock. There is no circular wait. There is no circular wait. Okay. So A request R, yes allocated. C request T, C request T, yes allocated. A request yes. A request yes, yes. But now currently yes is free, no? So it got allocated. Then C request R. C is requesting R. Cannot be allocated, no? C is requesting R because R is currently with A. Right? C is requesting. Look at the fourth step. C request R. C is requesting R. But it cannot be allocated because R is already with A. So now what the C should do, it will go to usually waiting state. Okay. Remember C is waiting to use R. Okay. In the fifth step, A releases R. A is what? Releasing R. Who's waiting to catch R? C. So it got it. It got it. Okay. C is requesting for R. After A released R, see the direction. C now R is with C. In this diagram, C requested R. In this diagram, R allocated to C. R is allocated to C. Okay. Now there is no deadlock. Okay. So that is no deadlock. Okay. Now how we can deal with the deadlock? How we can deal with the deadlock? One thing is very funnily it is given in your book, which is called the ostrich approach. Ostrich approach means what? This circular wait, no, in a multi-processing system, there are so many processes. Assume that there are 10 processes. This circular wait will happen very rarely. Very rarely it will happen. Okay. So as it happens very rarely, we will just ignore it. That means the system will not have any algorithm to detect, recover, prevent, no, nothing. Let it come, Okay. So if it comes, what will happen? If it comes, the system will hang. You have to restart it. If you restart, all this allocation, all these processes, everything will be what? It will be released. Matlab, it has to start from first. Okay. So that is one way. Okay, bad things happen. Let it happen. Okay. This approach is not commonly used. Okay, but in a very busy multiprocessing system, no, it will not be handled. There is no solution to if a deadlock happens. It will not be handled only. It will not be handled by the system. Then what will happen in real time? In real time, as a user, you will sit in a system. You will not know why the complete system hang up. Okay. So what usually you will do? You cannot find out the reason, no, if your system hung. Then what you will do, simply you will shut down the system and you will restart it. Okay. So then in the multiprocessing system, everything will be released. Whatever resources allocated, everything will be released. Then again, you have to start. So in the second start, we can say the deadlock will not happen maximum. Okay. So that is the one way. But next one, we are not going to bother about this, the first one. Second is detection and recovery. That means we did not prevent. The system is not having any prevention method to completely avoid the deadlock. Let it come, but after it comes, we will apply any of the recovery solution, any of the recovery method. This is another way. This is another way we can deal with the deadlock. The system can deal with the deadlock. The first one, let it come. It is on the head of the user. Whatever he has to, no other way, he has to He has to shut down the system. Okay, to release everything. The second one, the deadlock will occur very rarely, but there we implemented algorithm. System has algorithm to detect it and to recover it. Okay, this is a second way of handling the deadlock. Third way, some of the systems are very dynamically having the deadlock avoidance algorithm. Okay, in those systems, deadlock will not come at all because the algorithm has been implemented such a way that the deadlock will not occur. That means the resource allocation should be like that. Whenever the operating system allocate the resource, it should be very cautious that yes, if I allocate this, will deadlock happen or not? Will it happen? There is a chance to happen? No, it will not allocate the resource. SA also we can We can completely avoid the deadlock. Okay. Then prevention. So now here dynamic avoidance means what? Careful resource allocation. When the operating system allocate the resource for the processes, it will allocate such a way that the deadlock will not happen. Okay. But prevention, negating one of the 4 necessary conditions. We saw 4 conditions to occur the deadlock. In that, any one of the conditions we release, then the deadlock will not occur. That means either we should not implement the mutual exclusion, or we have to put the system in a preemptive system, like that. Any one of the conditions which will cause the deadlock is released. Through that, we can prevent the deadlock. Okay. Okay. So here I finish today's lecture. Continuation of this, how the detection and recovery will happen, how we can avoid, how we will prevent, we will see in the forthcoming lectures. Okay.
Hello, ma'am.
Okay. Thank you, students.
Hello, ma'am.
Yes, sir.
Ma'am, can you
One second. Yes. Tell me now.
Ma'am, can you provide some kind of question bank for the semester exam like you provided in the first sem?
Question bank.
Yes.
Even if I give question bank, no, it will cover whatever I taught. Is it okay? Whatever I taught, I will give in the form of questions.
Okay, ma'am.
So the why no, I am also helpless because your multiple choice questions and your descriptive questions, I asked like to cover all the whatever I taught, everything will be covered. Okay. So I asked a question like that only. So why I asked it like that? Because there are many things I did not teach in operating system. Okay. I know because in the short time I can't cover. Okay.